Ready. My
Good
wife just
morning.
texted me saying that there are still people waiting in the lobby or something. So if someone can let them in. Let's, we can start.
Good morning to one and all present here. It gives me immense pleasure to welcome you all to the 26th talk of TransTech Research Talk Series organized by KSCSTE National Transportation Planning and Research Center NATPAC. Before delving deeper, let me take a few moments to enlighten about the institute. NATPAC is a premier research institution functioning under the Kerala State Council for Science, Technology and Environment, spearheading transportation research including transportation planning, traffic engineering, pavement engineering, highway design, road safety, intelligent transportation systems, inland water transport, etc., and promotes sustainable development initiatives to mitigate traffic and transportation challenges faced by the state of Kerala. This talk series is yet another unique venture of NATPAC designed to explore diverse topics from cutting edge technologies to sustainable solutions. Here we will be featuring eminent researchers who will share their expertise and valuable insights, inspiring future research and development in the transportation sector. Today we have with us Mr. Salil Gokhale, Director of Consulting Applied Research Associates ARA, for sharing his valuable insights on the topic Pavement Engineering State of Practice. This talk is organized by the Transportation Planning Division of NATPAC, collaborating with the Association of Transportation Professionals of Indian Origin, ATPIO. ATPIO serves as a global forum for transportation professionals of Indian origin to address industry challenges, exchange ideas, and mentor young professionals. ATPIO also promotes the sharing of knowledge and technology between India and the world, supporting the advancements of transportation systems. Now, I request Dr. Shahim S., Principal Scientist and Head, Transportation Planning Division, to deliver the welcome address.
Very good morning to all. The KSCSTE-NATPAC has launched a technical discussion series called TransTech Talk Series, which focus on different aspects of transportation sector. This series will bring together renowned experts from diverse transportation fields globally, who will share their insights, experiences, and innovative research ideas. The inaugural talk of the series was conducted on 10th February 2023 through online platform where more than 200 participants from eminent institutions, departments from all over India attended. The inaugural address was given by Dr. Professor Tom V. Matthew, Chairman, Research Council, KSCSTE-NATPAC, and Professor IIT Bombay. The first talk in the series was delivered by Dr. Srinivas S. Pulgurutha, Professor and Research Director of the Department of Civil and Environmental Engineering at University of North Carolina, on the topic Advancing Crash Frequency Prediction Modeling Using GIS. The talk series was then carried forward by eminent faculties and experts like Dr. Rajiv P. Malik, Professor R. Jayakrishna, Engineer Tony Matthew, Dr. Varun Varghese, Dr. Sunanda Disanaige, Dr. Neeraj Buch, Professor Sabya Mishra, and so on. The 26th talk in this series, organized by Transportation Planning Division of NATPAC in association with Association of Transportation Professionals of Indian Origin, will be delivered by Mr. Salil Gokhale, Director of Consulting, Applied Research Associates, USA. It is with great pleasure and that I stand before you today to extend a warm welcome to our distinguished speaker, who has graciously accepted our invitation to share insights and knowledge in the realm of pavement engineering state of practice. After this presentation, we will have a question and answer session where you can pose your questions and engage in a meaningful dialogue with Mr. Salil Gokhale. Feel free to interact, to participate actively. Once again, thanking you for being here today, and let us give our warmest welcome to Mr. Salil Gokhale as we eagerly await the insights he is about to share. Thank you.
Thank you, sir, for the welcome note. Now, I would like to invite Sri Anish Kini, scientist, to introduce the speaker to the audience.
Thank you. Good morning, one and all. Mr. Salil Gokhale has been an ATPIO member since 2005 and currently serves as the president of ATPIO. Over the years, he has volunteered for numerous ATPIO initiatives and has served in other positions, including board member, treasurer, vice president, and as an unofficial secretary. Mr. Salil received his bachelor's degree in engineering from the College of Engineering, Government College of Engineering, Pune in 1998, followed by a master's degree in civil engineering from the Pennsylvania State University in 2001. In addition, he is also pursuing an MBA degree from the University of Illinois. Mr. Salil is the director of consulting at Applied Research Associates, ARA, and oversees ARA's Pavement Consulting Engineering Group across the USA and Canada. He has more than 24 years of experience in pavement engineering and is a licensed engineer in Texas and Florida. He has significant experience in managing pavement evaluation, analysis, and research projects on highway and airfield pavements in the USA and many overseas locations. His areas of expertise include implementation and upgradation of pavement management systems, automated and manual pavement condition surveys, GIS integration, non-destructive pavement structural testing and design, pavement profile measurements, friction testing on roads and airports, and accelerated pavement testing. Mr. Salil has extensive international work experience and has performed projects in various countries, including Argentina, Colombia, Japan, Indonesia, India. The list goes on. From 2009, he has collaborated closely with the Central Road Research Institute, CRRI, in New Delhi, with helping to set up their ATP program with a heavy vehicle simulator. He is a member of the Indian Roads Congress and maintains close ties with the Transportation Research Group of India. Thank you. Welcome you, sir.
Okay.
Sir, over to you, sir.
All right. Thank you so much for the kind introduction. Just making sure that everyone can hear me okay and that you can see my screen.
Yes, sir.
All right. Thank you. Well, thank you, Anish, and thank you everyone at NATPAC. A very good morning to everyone from India. Namaskaram, namaste. It's a little late at night here, but I'm used to staying up, so no problem. You've already introduced me, but I'll do a very quick introduction of myself, just to give everyone a quick outline of the presentation today. We'll do some introductions, introduction to pavement engineering, what functional and structural performance of pavements mean, what condition evaluation and testing entail, what the next generation of pavement evaluation is all about. And I do want to talk a little bit about accelerated pavement testing, and we'll finish up the presentation afterwards. I hope you have told everyone that there's an exam at the end, and we'll give out question papers afterwards. Just joking about that. Very quickly about ATPIO. I know you have introduced ATPIO, but basically we are here in the US, a lot of Indian people in the transportation, engineering, and planning realm, a lot of people in academia and consulting practitioners. We came together to unite our community and provide a transfer and exchange of knowledge and relevant technology between India and other countries. And we usually meet up at the Transportation Research Board's annual meeting in Washington, D.C. And yeah, we have several initiatives, including student sponsorships and scholarships, and we are initiating a ATPIO awards and recognition program for people from the Indian diaspora. Now, our website is atpio.org. We are reconstructing it, but please do take a look at our website. Very quickly about just a little personal introduction. I know you've introduced me. That I'm looking forward to receiving my MBA. One more month to go, so May 2025 is when I'll get it. Here in the US, I've been connected with the Indian community throughout my stay here. I've been here in the US since '99. With ATPIO, I've been with them since 2005, serving various positions. I've also served as a board member of the India Cultural and Education Center when I lived in Florida. And here in Austin, I'm a life member of the Austin Marathi Mandir. So connected with the Indian community, connected with all our people. And just some photos here on the side. I've been very fortunate to have gone around the world to several countries, so many of them for work and several of them for traveling and vacations. Professionally, I'm with Applied Research Associates. I'm the principal engineer and director of consulting. I manage 6 offices. And as you mentioned earlier, I've had the good fortune of being able to go around the world to see pavements in many different countries. And yeah, we manage pavement management, design, evaluation projects all over the world. I've been to more than 75 airports, a lot of military installations, and I do have a little bit of work experience in India. The reason I got introduced to pavement engineering to begin with was when I worked in India after graduation. I got to touch a little bit of the Mumbai-Pune Expressway, which was the first expressway in India, and that opened my eyes to the new realm in highway engineering and pavement engineering. Then I've also worked in Mumbai on a bridge project and in a highway project in India. So just a little bit about the company that I work with, Applied Research Associates. We are essentially a defense contractor. Most of the company works with the Department of Defense here in the US. They do all kinds of very cool things. Weapons, explosives, missiles, anti-terrorism, a lot of things that are quite in the secret realm or sensitive realm. But we do a lot of national level security. The part of the company that I work with is in the transportation sector of ARA. And if you type in pavement engineering or transport engineering in Google, our name comes up. We work in airfields, transportation asset management, geotechnical, and structures, anything connected to pavement engineering, really. And on the research side, we also do a lot of research. I'm sure a lot of you must have come across the Ashtoware Pavement ME software, which is used here in the US for pavement design. This is a nationwide effort. ARA does write the software, we maintain it, and ARA's researchers have actually produced a lot of the background theory and models that go into pavement ME. And National Cooperative Highway Research Program, or NCHRP, we published several reports, also for the Airfield Cooperative Research Program. So you can look us up. If you need any additional information, also do look up ara.com/webinars. We have a wealth of free webinars online. We usually do them once every couple of months, and they are free to attend for everyone. So my topic today is to talk about pavement engineering. I'm a pavement engineer by trade, and I want to talk about where the state of affairs is related to pavement engineering and management here in the US and several other countries. So what are pavements? So pavements are the largest investment in infrastructure, right? In any country, any agency, you have highways, expressways, city streets, roads, airports. All of these form part of the critical infrastructure, and this is the single asset that influences economic growth. If you can get people and goods from one place to another in a good amount of time without delays, you'll have good economic growth. And pavements are complex, and they're built in a complex environment. You have all kinds of loading, weather, materials, etc. Pavements are usually ignored by a lot of agency owners because pavements don't fail catastrophically. They're not like a bridge where suddenly one day it breaks and you have a catastrophic failure. Pavements deteriorate gradually, and even if a pavement has failed, you can usually still go over it. So most agencies still treat these problems that are seen on the surface, and they don't treat the underlying cause of the failures. And this is not unique to any country. This is all over the world. Usually the treatment is reactive. You treat something only after failure has occurred and not proactively beforehand. So why are pavements complex, right? So we have a lot of different materials. You go from the southern tip of India to the northern tip, you have a lot of different types of materials. There are different processes in how these materials are produced, different construction techniques, different quality control measures. We have a lot of different loading scenarios. You have overloading, underloading, different tire types, pressures, and we have a lot of different environmental and weather conditions, ranging from very cold to very hot. And of course, in India, we have the monsoon. So the interaction of all of these different variables make pavements a very complex phenomenon to analyze. So how do we deal with pavement conditions? So pavement conditions, if we plot, condition, if you're generally defining what is a pavement condition, we start off with a brand new pavement. So it starts off at this excellent condition, which is brand new, nice and black, or if it's a concrete road, nice and white. And through the effects of traffic and aging, that condition deteriorates over time. And what we are trying to find out is, how does this deteriorate? Does it go in this shape here shown in this green curve, or does it go straight down, or does it remain flat? All of those complex variables that I showed you earlier, they all play into how pavements behave. Why should we be concerned? Because to treat a good pavement by doing preventive maintenance, let's say if the cost is 1x, if you let the pavement deteriorate to where it goes into this good to fair, maybe poor category, now you're going to do some milling and replacing or doing some paving. Now the costs have turned 4 times that amount. And if you let the pavement fail and you have to reconstruct it, then the costs are 12 to 18 times. So it's imperative that we optimize, where we are treating pavement, where we are treating the conditions, and how do we optimize the limited budgets that most public works agencies have. When it comes to pavement performance, we define pavement performance in 2 broad categories: structural and functional. Structural is the health, is the ability of the pavement to withstand loading without developing appreciable distress. And then functional is your riding quality. How does the pavement ride? When you drive a car, or when you're riding a bicycle or one of your 2-wheelers, are you getting a smooth ride? Is it a safe ride? Is the road having enough friction? These are functional. But both these performance measures are interrelated, because if a road is rough, then it generates a very high dynamic load, which leads to structural distress. And then the riding quality, if the riding quality is impacted by distresses, then that causes more problems. So this is a cyclic phenomenon. Both these types are highly interrelated. So why would any agency collect information about pavement conditions, right? I mean, why do we want to know what the condition of our pavement is? And again, I'm calling pavements as a broad term for any road, highway, airport, city, street, etc. The generic term is pavement. So most public works agencies need to manage their network. So let's say for the city of Cochin, maybe it has, 1,000 kilometers worth of roads. Public Works Department or the municipality of Cochin needs to know, okay, we have this network, what condition it is in, which roads to fix, when and where. And so to check the conditions, we need an objective methodology, and not just something subjective where you send someone out and he says, yeah, I think the road is okay, I think the road is bad, no, maybe it is good. No, we need an objective methodology to measure these conditions. Then these conditions are used to forecast maintenance, repair, and reconstruction requirements. And most importantly, agencies need to find out what budget is needed. How much budget do we need per year to actually keep the roads in a decent condition, how to improve conditions, and what to do about catastrophic failures when you have like really bad washouts or anything like that. So here in the US, all the state departments of transportation, they're required to collect data on the entire network, and they're required to submit reports to Federal Highways, FHWA. Airports, of course, airports are completely different animal. A lot of safety-related issues with bad pavements underneath aircraft. So airports across the world are required to submit reports to. Here in the U.S., they submit reports to the Federal Aviation Administration. In India, they submit it to DCG, DCA. Otherwise, in other countries, it's ICAO. So airports are required to maintain their pavements in good condition so that aircraft don't have any problems of sucking in loose pavement debris. And for most developing countries, cities and municipalities also use this data to manage their pavement networks at the city and municipality level. So very briefly, what is pavement management? How do these agencies manage their pavements? So pavement management is the systematic process of managing, maintaining, and upgrading a network of pavements. And typically, they will use something called a pavement management system, which is a system to regularly collect pavement condition data. It's a computer database and a mapping program that stores all the records in one place. And then there's analysis tools to evaluate the different strategies and suggest cost-effective options for that agency. So when we look at this holistically from a big picture perspective, how does the pavement management methodology, how does this approach work? So we start by having a network of roads. We have geographic information systems, or GIS. We have a map of all the roads in an agency. We have segmentation, construction history, materials, and then we have other factors like traffic, amount of traffic, different materials, soil conditions, etc. Then once that network is defined, we collect pavement conditions. And I'm going to talk more about how we collect structural data, surface distresses. IRI is a term that you will hear quite frequently in this presentation. It's the International Roughness Index, which is a measure of how bumpy or how smooth a road is. Rutting, friction, and then it's supplemented by geotechnical testing, coring, lab testing, etc. And all of these inputs combined give us our functional and structural performance for every single roadway. What do we do next? Then we have to do some analysis, right? We have to take all of these conditions, do some evaluation, make some determination about performance, find out the residual life. If the residual life is bad, or if it's expired, then we do some design. Most agencies are now turning to mechanistic empirical pavement design methods to find cost-benefit solutions and optimize their budgets. And then the work plan at the end and recommendations is that, most agencies will say, okay, we have this network, we have done all the collection and analysis. Here's our plan for the next 2 years, 5 years, 10 years, etc. And here's the budget requirements for it. End result is, we want to try and do savings at the end of the day. We're trying to save the taxpayer money by keeping the road network in good condition. And as you all are researchers, where does research fit into this? Well, we are doing research on materials, or we're doing research on pavement structures, or we're doing research on other construction techniques. The use or the outcome of that research needs to be fed back into the cycle so that whatever good things you're finding out from research can be fed back into this loop, and that you're getting the benefit from this research. So this is where accelerated pavement testing comes in, and I'll talk about that a little later on. Just to round up the pavement management cycle, so we have a system, we update it with different condition scores, we do some modeling and pavement performance decision trees, find out what kind of treatment toolboxes we have, then we do some budgeting analysis to find out condition deterioration as well as amount of money required. And at the end of the day, we want a practical plan that can be put in place, and then you follow that plan. This is just like your asset management that you do at home, where you invest some money into a particular mutual fund or shares, and then you're following a strategy to make sure that your asset actually grows and develops. Commercially available software, there's a bunch of commercial software out there, ranging from Paver. Paver is a Corps of Engineers product. This is the most economic. And then you have all these other online-based StreetSaver, Cartograph, Agile Assets. World Bank has the HDM4 software. I know a lot of agencies in India are using RAMS, and then others from other vendors. But the main idea is that you implement, update the conditions, analyze, maintain the system, and then repeat the process. There has to be a repetition and a cycle to do this. So let's take a quick world tour and look at a few conditions around the world. These are photos that I've taken, so please bear with me. Some of them are not very good quality. I think you can recognize this. This is Cape Town, South Africa. This is a rural South African road which had a lot of cracking, so I thought I'd show that as well. In Mexico, I was actually quite impressed with the roads in Mexico City. Another picture from Mexico City. Indonesia, very similar conditions to India, a lot of two-wheelers, pavement conditions also very similar to India. This was a nicer road in Indonesia. This was an expressway. Then I took this photo from a bridge in Nagasaki in Japan. And first, when I took it, I thought that there must be something wrong with this photo because it is so super squeaky clean. Not one piece of paper lying around anywhere on this road. But this is how Japan is. Costa Rica, a central mountainous country in Central America. I've been there several times. They've done a lot of good work in pavement research. So some conditions in Costa Rica. And because it's a very hilly country, they have a lot of failures as well. They get a lot of rain, very similar to, the southern parts of Kerala going up towards Periyar and the hill stations. This one is from Greece, Argentina. This is a city road in Buenos Aires. This is a rural gravel road in Patagonia. So Patagonia is a very remote place in South America, but it's magnificent. It's beautiful. A lot of gravel roads there, but they've actually maintained the gravel roads pretty well. Here's a rural interstate in the USA. Here's a rural city road in the USA. We also have a lot of very bad roads in the US as well. The US is not all good roads only. We have a lot of bad roads. And then coming to India, here's my favorite road. Like I said, Mumbai-Pune Expressway. This is now 28 years old. It was opened in 98. It is showing signs of deterioration now, mostly all concrete, but yes, it does see a lot of traffic. So some rehabilitation will be going on Mumbai-Pune Expressway. This is the brand new Atal Setu Trans Harbour Link. Just beautiful, excellent road. It's a bridge mostly, but done it really well. You might be familiar with some of these conditions throughout India. We have, this is from New Delhi. See this delamination coming off of this road. This is Pune-Satara Highway, so showing signs of fatigue cracking, load-related distress. And we have some very nice roads too. This is another part of Pune-Satara Highway with really good conditions. And then last December, we went on a little road trip in Gujarat. And quite frankly, I was very impressed with the roads in Gujarat. They've put in a lot of new concrete roads, lot in very nice conditions. Another one in rural Gujarat. And I'm sure a lot of you are familiar with this situation as well. We have expressways and we have divided highways, and then you see these people coming from the wrong side. So thought I'd just put that in there. I took this picture and I show it to quite a lot of people because this is a concrete road from Agra, and I have no idea whatsoever what has happened to this road, why it is in such a bad shape. And I actually found a road in Cochin. I had visited Cochin several years ago and didn't get a clear shot of the road, but here's a picture from Cochin. This one is from rural Maharashtra. Again, a lot of you traveling around in India know the conditions. We have really good roads, and then we also have some really bad roads. Another one, rural Maharashtra. And then this is a thoroughfare city street in New Delhi. So we have some combination of good roads and we have a combination of bad roads. Now we need a system to put it all together, and we need a system for evaluating the conditions. So when we talk about pavement conditions, I mentioned we have two broad categories. One is functional and one is structural. So I'll talk about the functional evaluation first. The evolution of technology over the years, in the 50s and 60s, we had the straight edge. So functional evaluation is mostly about riding quality. It's about riding quality and how the user feels when they're actually driving a vehicle. So that roughness or smoothness had to be measured. So back in the 50s and 60s, the straight edge and profilographs were developed, and they had to be manually pushed or dragged behind a tow vehicle, and you'd get an index that would indicate how bumpy the road is. And then in the 70s, the bump integrator was developed, which accumulates the suspension movement as this trailer is dragged along. I believe this is still in common use in India. I know CRRI also manufactures this. Starting in the late 80s, when lasers became a little bit more affordable, laser profilers started coming into the market. And in the mid 80s, a big study was done by the World Bank to develop this index called the International Roughness Index, or IRI. This is a global index, pretty much transportable to any place in the world. an IRI of X meters per kilometer means the same thing in India, and it means the same thing in the US. So practically all the developing nations, I'd say even a lot of developing and developed nations, are all switching their specifications to IRI and the measurement techniques that go along with it. And as technology, computers, electronics became more common and more available, vendors started manufacturing more complex fans. I said, well, if we are measuring the roughness, how about we measure rutting? How about we take some photos? How about we capture some other elements? So these 3D pavement imaging vehicles have become very popular now. You might know these as network survey vehicles in India. We have about 6 of these in our. In the future, is it AI based? Will we reach a point one day when we can just take satellite photographs and get conditions? Maybe. I think that's also coming. The imaging technology itself has also undergone a lot of change within the last 10, 15 years. We've gone from film and video to area scan cameras to laser measurements to now the most common one is this LCMS. And I'll talk about this two sensor system to a single sensor system. So the two most commonly used 3D pavement imaging systems in the world are these. One on the left-hand side is called LCMS, or Laser Crack Measurement System. This sensor is produced by a company in Canada, and they sell it to different integrators. So you have Dynatest, you have Rambo, you have ARRB, you have ICC, you have many others around the world. The one on the right is by a company called Pathway Services, and they have a single sensor. So the one on the left has 2 cameras. This one has a single camera. The resolution and scanning width is about the same, 4-meter scan width. Both these systems are designed to produce 1 millimeter resolution of the pavement surface. So you drive this van along the road, and you capture a continuous pavement photograph and a ranged image of the pavement surface. And then the computer algorithms will pick out cracks that are tiny as 1 millimeter in width. And both these systems are shadow free. So they have an illumination source that lights up the pavement. So as I said, vendors started putting in more sensors to say, okay, if we are driving this vehicle, then let's collect more and more data. So this path runner system that we have, it has a 3D pavement imaging system. It has 4 right-of-way cameras that give you a nice panoramic view in the front, a 360 camera on the top, so you can do your like a Google Street View spin around. It has a LiDAR sensor in the back. The profiler gets roughness, rutting, faulting. We also collect macro texture, and then grade, cross slope, roadway geometry. All of these elements are captured. So as you can understand, these vans are fairly expensive, but they do collect a lot of data. Our system collects, without the LiDAR, we are collecting 3 gigabytes of data for every mile of road that we scan. So it is a lot of data to manage and a lot of information to assimilate. What do we do with all these images and everything that's been captured? Well, we still need a standard way. We need some guidance on how to interpret these distresses and how to keep them objective. So here are some examples for distress rating guidance. There are 2 ASTM standards. One is 6433, which is for roads, D5340, which is used for airfield pavements. And then highway agencies also use what's called long-term pavement performance, or LTPP. This provides very clear guidance on how to classify these distresses and how to make sense of it. And once we have distresses identified, we want to say, okay, I want to score for whatever segment of road that we've just tested. So very common index that is used around the world is called PCI, or Pavement Condition Index. And it goes from a scale of 100 to 0. And the way the score is calculated is based on, say, you capture all the distresses in a particular section. You have distress types, you have distress quantities, and the severity of distress, whether it is low severity or medium severity, high severity. All of these go into a iterative algorithm, and then the computer program basically calculates a score which goes from 100 to 0. So 100 is brand new, excellent, there is no distress, and 0 would be total failure. Usually roads are somewhere in between. But the PCI score essentially indicates the structural integrity and surface operational conditions of that road. So here you can see three different color coding schemes that many of my municipal agencies use here in the US. What does this data look like from these 3D scanning cameras? So we have two pictures on the left-hand side. One is a 2D image and one is a 3D. So the sensors are actually capturing a depth to the pavement surface, and so you can see all of these cracks. And the computer algorithms identify the locations of these cracks. So this is an example of alligator cracking. Most of our projects, what we do with this is, we take all of these distresses and we map them out in great detail, especially if it's a rehabilitation project or a resurfacing project. We provide a lot of detail with the vans. For multi-lane highways, there is another example. This is a 8-lane highway outside of Dallas. And so we captured the data in all directions, marked out all the distresses, and then converted them to an easier color-coded scheme so that this toll road operator agency can now see which lane has more distresses and which lane is in a worse condition compared to the others. Here's one more example. This is outside of Seattle. So this agency manages around 900 kilometers of, 900 kilometers of arterial roadways. And so their color-coded combinations for all these PCI scores are shown here on this map. I mentioned friction testing earlier. Why do we need friction testing? Because, of course, here in the US, we have higher speeds. Outside of Austin, there is a road that has the highest speed limit. The posted speed limit is 85 miles an hour. So what is that? Roughly 140, 150 kilometers an hour. When you're driving that fast, of course, you want to make sure that if you brake your vehicle, that the vehicle has enough friction characteristics with the road. So roadway agencies here take this very seriously. States maintain a large database of friction characteristics, and they will use something called a very commonly used as a locked wheel friction tester, which is a pickup truck, and there's a trailer behind. And the way this works is you drive at constant speed, and this machine basically applies a controlled film of water in front of this tire. And as the vehicle drives, a brake is applied. As you can see, this tire brakes, and then horizontal and vertical loads are computed to find out what the friction characteristic of that road is. And there are guidelines to say, okay, if the friction number falls below a certain threshold, then that means that there's very little texture and that the potential for hydroplaning or skidding is high. So states will take corrective measures to make sure that people don't skid off, especially on curves and especially on downhill areas. Okay, so now let us talk about structural evaluation. So what do we mean by structural evaluation? And again, a little bit of evolution of technology here as well. 40s and 50s, Mr. Benkelman developed the Benkelman beam. This is a single sensor which measures the deflection of the pavement surface. You put it underneath the tires of a truck, and as you drive past, you measure how much the road bends or deflects. We have the deflectograph and the vibratory deflection devices. Pretty much no one here uses any of these three devices. Since the advent of the falling weight deflectometers, or FWDs, starting in the late 80s, almost every agency here that I know of has switched to FWDs. I worked with this company called Dynatus for 12 years back in the day, and this actually was a lot of our bread and butter for evaluation of pavement. So I'll talk a little bit more about FWDs. But I'm also going to talk about the next generation of testing devices, which is traffic speed deflection devices. I have a whole set of slides for you on that. So how does the FWD work and what does it do? So basically, the FWD applies an impulse load to the pavement surface to simulate a rolling truck tire or an aircraft tire. And these FWDs usually come in two flavors. One is an FWD, which applies a load between 6 to 120 kilonewtons, and it's heavier brother, hence the name heavy falling weight deflectometer, or HWD in short. And this is meant to simulate all the way up to an A380 or a B747 tire, the amount of stress that a fully loaded tire applies to a airfield pavement surface. Why do we want to use load deflection data? So first of all, we have done the functional testing. We can see things on the surface, but we don't know what the health of that pavement is. So we need structural testing to be able to do this. So load deflection data is used for determining structural capacity and health, finding out what the remaining service life is. If you're doing new design or overlay design, then what thickness of overlay is required to carry the traffic. In parts of the US, we have a lot of snow in the winter, and then when the snow melts, the ground turns pretty mushy. Very similar conditions to our monsoon. What happens in the monsoon? You get a lot of saturation, subgrade strengths weaken big time. But in the US and other countries, they impose seasonal load restrictions. So if you have big trucks, they can only carry a certain amount of load, especially if the pavement has weakened in the seasonal thaw cycle. This picture here on the right, we did a project for SpaceX because they wanted to find out whether this road outside their facility was strong enough to make sure that this rocket could be moved to the launching pad without any issues. So yeah, we do a lot of FWD testing for roads and highways. Like I said, this used to be our bread and butter for pavement design projects. I don't have a lot of slides on airfields, but we do work here. Airfields are very critical. This is a satellite picture of Atlanta International Airport, the busiest airport in the world. It's got 5 main runways, and pretty much this traffic coming in and out, all shapes and sizes of really heavy aircraft using these. So why do airports want to maintain their pavements in good condition? Well, they want to make sure that all the pavements, so the runways, taxiways, aprons, ramps, that they are strong enough to carry whatever aircraft is coming in, and that any movement of that aircraft on those runways or taxiways will not produce damage. If there is damage on the pavement surface, if there's a breakage or if there's loose material that is caused because of pavement distresses, those can get sucked into the engines. And you definitely don't want any, that's called FOD, foreign object debris. You don't want any pavement-related FOD to get sucked into aircraft engines, because that would definitely be catastrophic. So airports are required to test their pavement surfaces and report this to the governing organization. They're required to say, okay, if an airline tomorrow says that, yeah, we're going to start bringing in 777s, or we're going to start bringing in A350s, that the pavement is strong enough to handle that. Airports also are required to produce a PCI report, make sure that they're in good condition. And one of the biggest things that airport operators do is they measure the friction on runways. And so here in the middle, we have a runway friction tester, which measures the friction characteristics of that runway. Every time an aircraft lands on an airport, each tire of each gear assembly of each aircraft deposits anywhere between 250 grams to 500 grams of rubber per tire. So you can imagine, I mean, even Cochin International Airport, you have a lot of big aircraft coming in from overseas. Each of those aircraft, each time it lands, all of this black rubber deposit that you see here, this gets deposited. What does this do? This reduces the friction. So as the plane comes in and it lands, it's braking, reducing engine power, doing the reverse thrust, etc. But if there's not enough friction on the runway surface, there's a chance that the aircraft actually can skid out, and we definitely don't want that to happen. So we do runway friction testing. Here's a friction graph on the side. Airports will monitor this very carefully, and they will use either chemical treatments or sand or water blasting to get rid of all this rubber deposit on airports. Similar to what I showed on the highways, airports also produce a color-coded visualization map so that they can manage their airport pavement network effectively. Along with the structural testing, we supplement that with ground penetrating radar. What is GPR? GPR is a series of antennas inside a case. And, they're sending radio waves inside the pavement, and we use this for subsurface investigation. So we have the structural response of the pavement from FWDs, but we also want to find out what the layer structure is. So we use GPR. We want to find out information about voids, or if there's any stripping or pavement defects underneath the pavement surface. And we also use it for identifying utilities, or if there's something right underneath a pavement structure. Here's an example of utility mapping that we did. We scanned this whole area and we found all these pipes and utilities underneath the structure. So just a quick sip of water. All right. So what is the next generation of pavement testing, and where is the industry heading around the world? So we've talked about the different vans. We've talked about falling weight deflectometers. We've talked about structural and functional testing. The next generation is something called traffic speed deflection devices, or TSDDs. And why did a lot of agencies want this? So they're saying that, well, falling weight deflectometer testing is good, but one of the main drawbacks of FWD testing is that it is discrete. You have to drive the pickup truck and the FWD trailer to a spot. You have to stop. You have to take the measurements, even if it takes only 15-20 seconds. But you still have to stop, which means traffic behind you has to stop. And here in the US or European countries, we have to have proper traffic control. Traffic has to be diverted. We don't want to cause any accidents. So agencies were saying, well, we don't want discrete points. We want the full picture. We want a continuous measurement of the pavement health. How do we do it? So about 20 years ago, companies started developing TSDs. The most common or the most prevalent one right now in the world is this device by a company called Greenwood. They're the ones developing this. The company I worked with, we also developed a machine called the Raptor. This has now since been sold to Ramble. And then the newest one on the market is a device called the Measure Road. So it's essentially the same technique, same measurement principle, but it's by a different manufacturer. And these types of TSDs have now been in service for quite a long time. Australia, New Zealand, South Africa, they've been using this for better part of 15 years. A lot of testing has been done in the US as well, and now it's heading over to other countries. So biggest advantage is that, yeah, this is a full-size truck, and it's applying a full-size truck load to the pavement, and it's measuring the structural response of the pavement as it drives. So how does it work? This is from the Raptor device. So let's assume that this is an undeflected road. You have the truck tire applying stress to the pavement surface. So the pavement surface essentially deforms or deflects or bends, whichever one you want to call it. What we are trying to measure is this deflection basin produced by this moving load. And whether it is with standard lasers or Doppler lasers, different vendors have different techniques. But this is the measurement principle. Essentially, as this entire system is driving along the road, the electronics inside the truck are capturing the deflection basin. If we can get a deflection basin in the road, then we can find out its structural performance. So here's a schematic from the Greenwood device. They've added right-of-way cameras. They have some solutions. So this is a full-size semi-trailer as we call it here in the US. There's a measurement beam inside, and there's a whole bunch of Doppler lasers. These lasers measure the deformation. And in my presentation, there's a link. Please feel free to check out Greenwood Engineering when you get a chance. Then I reached out to my friends at ARRB Systems, Australian Road Research Board. They're a private company now. And what they have done is they've taken the Greenwood TSD. So this is still a Greenwood TSD, but they have greatly modified it, and they've added in their own software and their own analyses algorithms to produce what they're calling the iPave system. And my understanding is that ARRB Systems is going to bring one of these trucks to India very soon. So Thanks to ARB, I'm showing some of their slides in this presentation as well. So again, we talked about the functional performance, which is what we see on the surface. What this system was saying is that we cannot rely only on the pavement surface to capture conditions. We need the pavement health. We need to measure the subsurface conditions as well. And so, as an example, they tested this road here in the US. This is a rural highway in one of the states. And as you can see, the road is nice and smooth. There's not much of cracking or surface deterioration that they could see at this time. But when they analyzed the TST data, they found that this section was weak. So like, what is going on? So they had someone go out and take some pavement cores. Like, so let's go out and see what's happening underneath. So when they took some cores, they realized that there's a huge issue of asphalt stripping out. All these cores, you see how much the asphalt has deteriorated due to moisture damage, and that this road is, maybe it looks good on the surface, but it's not really good underneath. So this was the picture on the left-hand side. This was a picture taken in June of 2018. And then 4 months later, when they went back, 4 months later when they went back, of course, weather conditions had changed. But look at how much damage has been caused in this road because of the subsurface conditions in the asphalt material. So the TST was able to pick that up. So what ARRB has done basically is we talked about all the different measurement methods. They said, well, if we are measuring deflections, why don't we add other sensors to basically capture the one big picture of the road in one system? So they added a digital imaging system. They added the profiler, texture laser, of course, GPS. Everyone has nice GPS now. They added an inertial measurement system, the 3D GPR, and all of these systems are now integrated inside ARRB's Intelligent Pavement Assessment Vehicle, or IPAVE as they call it. And this system basically collects data. You drive this truck, it's literally driving a truck down the highway, and it is collecting tons and tons and tons of data. So ARRB collects this data, and then companies like ours, ARRA, we are specialists in analyzing the deflections and making sense out of it. So go to the next slide. What ARRB has also done is they've produced a really cool website that shows all of the data in here. So you see here, this is a road that they've tested. The red, of course, is showing areas of high deflection. So you can see this is a very badly deteriorated patch on this road, and it's supplemented by high deflections, high alligator cracking, and all the ancillary data as well. So this is a very nice website. You hit play, and it basically shows all the information. Lot of good information is being captured by the ARRB system. They have two case studies that they asked me to possibly demonstrate. So here's a road that was captured. You can see surface cracking. So they're like, well, the surface cracking, but does that mean that only the top layer is bad, or is the structure itself bad as well? But when they looked at the deflection data and the pavement information underneath, they see these spikes, and they're like, yeah, so this confirms that the structural distresses seen on top confirm to a weakening of the structure underneath. And in the second case, you have a pavement structure that does not show any visible cracking, but when they look at the deflection data underneath and the structural response to that pavement, it's indicative of structural problems here. So question is this agency going to proactively treat this road, or are they going to wait till big potholes appear and someone gets into a bad accident? Okay, so wrapping up on I know coming up on time. Talking about research, and so we've talked about pavement conditions, managing them, and utilizing this data to make a plan and to manage a network. How do we use research now to feed back into this loop and put our research to good use? So accelerated pavement testing, or APT, is the rapid evaluation of pavement and material performance under real life conditions. APT essentially means we are accelerating the loading applied to a pavement under controlled conditions. So we applied 20 years of truck traffic in as little as 3 months, and then we control the materials construction in a essentially a lab environment. And then the results are used for validation and calibration of design and construction. And so I've worked in this area for a good 15 years, and the research has shown that the return on investment, this is an expensive program to run. This is not a cheap program to run. Similar to what ARRB had, their truck is big. It's also very expensive. Even for us here in the US, it's very expensive to collect 1 day's worth of data. APT programs are the same. You have to put in the amount of research and the amount of funds to get feedback. But the ROI can be easily between 10 to 15 times. So that's something to think about. And most developed nations have some form of APT research in place. There are many full-scale tracks around the world that's actual simulation of real life. And barring that, then there are linear devices. There's one in India. I'll show you some pictures. South Africa, Florida, California, etc. Then there are circular tracks in France, New Zealand, Spain, etc. But what these devices do is essentially it is applying. This is one real truck tire, and this truck tire is loaded or overloaded vertically, so that we're applying a lot of stress on the pavement. And then you apply this load going back and forth in the machine to determine how much deterioration is happening to the pavement structure. So just some quick examples. This is the NCAT, National Center for Asphalt Technology test track in Alabama. This is almost a 2.5 kilometer loop, and this has been in operation for almost 25 years now. They use these big tridem axle trucks with heavy loads, and these guys just drive around and around probably for 14 hours a day. They apply pavement, they apply loading to the pavement, and each pavement section is about 200 feet in length. And the NCAT agency analyzes and reports all of the pavement performance measures on that. In ARA, we developed a system called Atlas. These are two of the biggest machines that are in play now. The one on the left is the Frost Effects Load Simulator. This is a machine that we are building for the Cold Regions Lab of the Army Corps of Engineers. And this is designed to work in sub-zero temperatures and applying super heavy loads to pavement surfaces. And the one on the right is something that we developed for the New Jersey Department of Transportation. It's called the Beast. And this is the first and one of the very few bridge testing accelerated bridge testing devices. So this device also applies a full truckload to a bridge deck structure. This is located in New Jersey. And then we also manufacture some of the smaller, more mobile versions. This one is in Louisiana. We have one in Canada that is mounted inside a truck. And then Federal Highways has two of our machines. And then the one below is in Illinois. The other company that I work for, Dynatus manufactures a machine called the Heavy Vehicle Simulator. I've been personally involved in many of these implementation and deliveries and setting up of these programs from China, Saudi Arabia, Costa Rica, California, Indonesia, Mexico. This is called the Heavy Vehicle Simulator. And also proud to be a part of the team that delivered this machine to CRRI in New Delhi. It is operational since 2010. The name of this machine is Ernst Zipkes, and Ernst Zipkes was the first Director General of the CRRI. So they named the machine after Mr. Zipkes. Federal Aviation Administration has a huge facility in New Jersey. This is called the NAPTF. This one actually is designed to test full aircraft gears and their effects on pavement structures. So whatever the FAA research team does and the advisory circulars that they produce is all coming from pavement testing using this giant machine. This one, they have a second HVS that they purchased several years ago. They're constantly doing pavement research for airfield pavement using these two machines. Army Corps of Engineers in Vicksburg, Mississippi, they have another of these big machines. This one can apply 440 kilonewton loading. They have a very big dual tandem bogie that applies pressure and stress to pavement structures. And they bought another one 5 years ago now. It's called the Titan. And currently they have retrofitted this with a rail axle bogie to test the railway pavement structure. So some very cool research being done by all these agencies. And how do they implement it? What do they take out of this research? How do they put it into a feedback loop for the state? So if we look at the South Africans, this is where the HVS technology came from. The South Africans have been using HVS practically in all aspects of pavement engineering since they started. So they have over 40 years of experience. Their entire design manual, their entire design methodology, asphalt mix design, concrete mix design is all a result of the research that CSIR South Africa that they have done over the years, and basically they have implemented it to practice ready for their local agencies. Similarly, with California, California has 35 years now of APT experience. They've developed numerous publications. CalME, empirical pavement design software, is a product of their APT program. I mentioned FAA and the Corps of Engineers. So, when they have heavy aircraft that they want to land in not so suitable places, what is the effect on the pavement structures? They do a lot of research. All the FAA advisory circulars also have been a result of their APT programs. And a great success story is this little country of Costa Rica. They purchased a APT device 12 years ago. And in the 12 years, they've developed their own mechanistic empirical pavement design guide. And there, people have published more than 200 journal papers. They've been fantastic. They decided very long time ago is that, yeah, we want to improve conditions in our country and we need the solid research to back this up. So they've been very successful in running their APT program. I worked with the Florida Department of Transportation many years ago, and again, the Florida Department has two devices because their ROI is calculated to be 12x. Results from the APT research are directly implemented back into statewide specifications and design updates, and this program is still going strong. So a lot of good research and a lot of good feedback into the pavement engineering and management cycle that I showed. So to wrap things up, objective pavement condition assessment is required. Of course, we don't want anything subjective. We want an objective method that encompasses functional and structural conditions. We want to implement pavement management systems that keep everything in place and provide the analytical tools to provide recommendations. And yes, to all your political leaders, please invest more in R&D. R&D is critical. We want to put the effects and put the output from R&D to good use. And last but not least, our ultimate objective is to keep the traveling public safe. We cannot control all accidents, of course, but at least they should not happen because of bad infrastructure. So with this, a big thank you to Anish and the company at NATPC, NATPAC. Thank you so much, and I'm grateful for this opportunity to provide some of the experiences that I've had, and I'll be happy to answer questions if you guys have any. Over to you, Anila.
The session is open to discussion. Any questions you can post in the comment section. Otherwise, you can directly ask.
Feel free to ask, folks. No formalities.
Viral sir. So welcome, Viral sir.
I'm sorry, say that again.
Hi, Salil. How are you?
Hello.
So,
Hi, Dr. Viragavan.
Yeah. Nice to see you.
Likewise, sir.
Yeah. Salil, I was just thinking as what will be the takeaway from your presentation to the participants of this webinar. So one thing that I am concerned is about the Astrover software. I don't think that anyone in India will be capable or making use available the software. It's not affordable. So at least some academic licenses should be made available so that the engineers can practice the use of Astroware. Even IITs do not have because it's so costly. And annual subscription is too high that they are not able to afford. Is there a way that the scientists of NATPAC and the academic students participate, evaluate the Astroware software?
So unfortunately, ARA does not control the pricing on Astro. Astro themselves controls. But as far as I'm aware, there is a educational license available. I know it is at a greatly reduced price. The caveat is that researchers and universities using the educational version should not use it for commercial
That is
projects.
true.
And I think that's a fair ask. But I will pass on your concern. One of the things that I've been tasked to do is to promote more Astroware payment ME is also, it's not something that you can just take and press some buttons, and it does need experts like yourself to actually know what's going on. But the amount of analytical tools and models available in Astroware is pretty much fantastic. It can be used and it has to be calibrated to local conditions. So I'll definitely pass on your comment about the pricing. We are working with Astro to have hopefully a free version for universities.
Yeah, that is true. Thank you for that. There are other issues. You had made a mention about the structural condition evaluation, functional condition evaluation, etc. The other problem which we are facing is that different FWDs are being used for the evaluation of the highways. No two FWD give the same number, same double ordinates. So what is needed is a calibration. There's only one agency in India which can calibrate. Again, it goes from one agency to second agency to third agency. How do we calibrate and normalize, standardize these falling weight deflectometers?
We have to set up a nationally certified calibration center, and only they will say whether this device, because I know in India, you have a bunch of Chinese devices, that some from Denmark, some from other countries, and so what's funny is that a lot of these deflection devices, whether it is FWDs or now the Raptor or Greenwood, they're all coming from this tiny country, Denmark. It's very uncanny. But at the end of the day, I mean, what UK does is they have appointed TRL as their certification agency. TRL has the calibration devices, and they'll put the machines through certain paces to make sure that the deflections, that all the geophones are calibrated, load cell is calibrated, and that the measurement response coming out of those devices matches their calibration.
Exactly.
So
that's what I'm looking for.
Yeah,
I'm looking for
CRRI would be a great resource to do this. I mean, they have a lot of experience going back. They've had an FWD with them also. They would be a good candidate to set up not just for FWDs but also for profiling devices as well. But we need to have some kind of a nationally accredited agency that basically, if you bring a new device in, it has to go through the trials and it has to pass all the calibration requirements.
And the third issue is the similar problem we face with the network survey vehicle. No two NSVs give the same number in terms of distances, severity, extent. Again, it needs calibration, normalization of the values. Again, we need an agency to standardize these NSVs.
Correct. Absolutely.
Yes.
Yeah, here in the US, we go through there's multiple levels of certification for the statewide work that we do. We have to take our vehicles to the Texas Transportation Institute, and they have a very rigorous course that we have to drive through at multiple speeds and multiple repetitions, and then we give the data to them. They will process it and they will say whether you have passed or failed. Only if we have passed, then we are allowed to use not just the vehicle but the operator also. Operator also has to go undergo certification testing. So certification testing is critical. I mean, the changes that the vehicles themselves undergo. I mean, even simplest stuff of vehicles, just like the bump integrator. Bump integrator has shock absorbers, it has tires, but as you drive that thing around, all of those have wear and tear, and then the calibration values changes. So there has to be almost like an annual certification program. Let's say if you're using an FWD on a national highways project, or if you're using an FWD as a certification device, it has to have some kind of assurance that this machine is working correctly.
Yeah, that's good. I think that an extension of what you have been telling is the application of the software for the back calculation of the model A values. We have the KGP back, LMOD, backfa and all, but we face problem whenever we want to evaluate an inverted payment, a composite payment, a full depth reclaimed payment. So we are not able to normalize the values. We have problems in back calculating the model A values. I don't know what software you would recommend for evaluation of the inverted payments, especially with a full depth reclamation payment sections.
I'm personally born and brought up on LMOD, so I will recommend LMOD. The finite element module in LMOD actually works really well. We have compared a lot. We have compared, Evercal, BackFAA, Rosie, all these other softwares. For us, LMOD works the best. It is also the fastest of all the back calculation software that we've tested. At the end of the day, Dr. Veeraghavan, back calculation also is not a simple process where you take some files, press some buttons, and you get numbers, and then you just assume that it is true.
Yeah.
Pavement engineering expertise is still required, and someone who understands where deflections are coming from, how they affect, or how the pavement structure and materials affect it. So it's not a fully AI process just yet. It does require engineering judgment. But yeah, my vote is for LMOD.
Yeah, that's fine. There are one or two small quick. I think we are now updating the IRC 115 and 117, which are used for the evaluation using a falling width effector meter. I think you had introduced one, Mr. Prem, for that, but I have not received any feedback from him about the code of practice that we follow. I request you to kindly have a look at IRC 115 and 117. I can share a copy and then comment as how we can update the software and the method of procedure for the evaluation using FWD.
I will be happy to.
Yeah. The one or two other question is that the friction tester, you talked about the locked wheel, but it has got its own limitations. We brought out a new code on skid resistance with the scrim, suggesting scrim. Each equipment has got its own limitations. Finally, the code is suspended. We do not know what is the reason. But what equipment do you suggest for the skid resistance measurement on project routes as well as for network level routes?
Yeah. So scrim is also, I almost put in a slide for the scrim device, because ARRB systems also has has a bigger scrim device they call iSave. Instead of iPave, they call it iSave. I have my concerns about the methodology of the scrim device to begin with, because it is a thin tire, small tire, and it is angled at 15 degrees, and it is measuring a friction coefficient. Is it true? Is it not? It does. The advantage is that it is continuous, and you can test a lot of kilometers with one vehicle. The drawback of the lock wheels, the skid tester, is that the water tank on these testers is limited, so you can only test 15, 20, 30 kilometers at a given tank full of water. And the fundamental problem with the lock wheel skid testing is the tire completely locks and it's dragging along the surface. We are calculating a skid resistance value. Well, this worked back in the day, and this correlated back in the day when most vehicles did not have ABS, and when you slammed on the brakes, the tires would lock up. So that is where the methodology came from. But when you look across the board now, practically every single car has ABS now. ABS doesn't allow the tire to lock up. It locks, releases, maximizing the friction. So is locked wheel testing the best way to do? No. The reason why it is popular here in the US is, again, because the states have maintained a vast database of measurements going back 20, 30, 40 years. And they're hesitant to change from one method, because now they know that these friction numbers should be within a certain range. Even now, you will not find a single state in the US that has published a specification that says friction number shall be XXX and above. They will never say it, because here in the US we can sue the public agencies. And so if someone gets into an accident and we go out and we test it, the friction number is 1 unit below their threshold, they're going to be liable for a lot of damages. So they will not publish a hard threshold. They'll say this is a guideline. if the friction numbers are within a certain range, we will take mitigative action. And if it's above that, then the pavement is probably okay. So here we are still using, most of the agencies are still using lock wheel skid testing. A scrim device is coming up. There are two companies in the US. It's a very expensive device also, by the way, $2 million from
Salil, one last question about this APTF. Both of us are aware that APTF at CRRA is not working. Is there a way that we can make the unit purchase for 14 crores lying idle and hundreds of research scholars? You said 200 plus research papers being published by other countries. Not even a single paper we are able to publish in India, even though we have the namesake APTF at CRRA. Is there a way that we can make it workable?
I'm sure there is, and I think I should talk to you offline about it.
Yes. I got many more questions. I think others let them talk. I will correspond with you through email. Yeah. Thanks, Kinney, for inviting me to join. Yeah.
Thank you. I saw a question in the chat, I think. There's a couple of them. While doing APT, how does the effect of aging, seasonal, climatic variations also brought in while testing with the effect of 30? Yes, great question. And the answer is no. There is no way to control environmental effects over that long. What the Florida Department of Transportation did was they built an environmental chamber called an APAS, Accelerated Pavement Aging Unit, which had a lot of radiant ultraviolet heaters. And what they would do is basically before testing a pavement section, they would age the asphalt for one whole month, like literally heat the pavement surface with very high radiation to simulate the effects of aging of the asphalt binder. Now, will that same effect be produced in the real world? Yes, except it's going to be over a long period of time. In the end, we are trying to simulate real life conditions in a controlled environment. So some of the effects of aging cannot be directly controlled. The application is if you have two different pavement structures or two different pavement materials and you test them under the same conditions, relatively within a period of each other, then the environmental effects would also be similar in the long term. And I think that is the objective. You can treat some of the most APT devices have a what they call an environmental chamber around it. They control the temperature inside the test section, whether it is a higher temperature or low cold temperature. They control the temperature inside the chamber, and the testing is done at a constant temperature. So hopefully I answered your question.
Thank you, sir.
Next question is from Shijit. When the residual life of a pavement is over, is it more beneficial to adopt CIR technology instead of providing an overlay, partial reconstruction, full depth reconstruction in terms of cost effectiveness, sustainability, and long-term performance? Short answer, yes to all. Why do I say yes to all? Because there is no universal answer to this question. I'm a big fan of CIR. I'm a big fan of FDR as well, full depth reclamation. I'm a big fan of recycling everything. I like to recycle practically everything. But is cold in place recycling suitable for all applications and all materials and all conditions? Probably not. Overlay, you can do an overlay if the underlying structure is decent enough, and you can get away with an overlay without taking off the existing asphalt surface, or if there's no deterioration in that asphalt surface, you're looking for a bigger structure. Full depth reclamation, I really like it. I'm a big proponent of it because you're taking a damaged surface, you're taking a damaged base, you're milling it all up together, injecting some either cement or asphalt into it, and providing an in-place, very nice, stiff, strong base that you then come on top and you put a new asphalt wearing surface on top. At the end of it, I mean, the decision to do which method is based on conditions, it's based on cost, it's based on availability, because you may want to do a CIR project, but there's no contractor available within whatever radius. Similarly for the other ones, the more common ones are milling and replacing, which there are more contractors for. So Yeah, there's no single answer, unfortunately. Again, it has to be evaluated based on multiple conditions. In California, for example, they provide an impetus, they provide an incentive for agencies to go for full depth reclamation, because their problem is, if we mill up this asphalt, it's producing a lot of RAP. What are we going to do with this RAP? We don't want to just go out and dump it somewhere. We don't want to recycle it either. We want to keep things in place. We don't want the extra fuel usage, extra truck trips required to haul off this material. No, we'd rather keep it in place, and a great way of doing that is with FDR. Third question. Hopefully I answered. If you have more questions, please do reach out. I'll be happy to elaborate more. Vasudevan is asking, while conducting GPR mapping of underground utilities, whether the device is able to detect pipes made of fiber, HDP, or soil. No. GPR works on the reflection of the ground of the radar signal caused by a change in dielectric constant of the materials. With plastic pipes or flexible pipes or earth pipes, the signal does not bounce back. We have this issue all the time. But a lot of times, what utility companies will do is, in a plastic utility pipe, they will have a metal wire that acts as a tracer wire, is what they call it. And if the tracer wire is in place, then the GPR signals bounce off of it, and you can find the depth to underground utilities using that tracer wire. But if it is plastic pipe only, it is very, very difficult to find plastic or fiber pipes. Okay. And Shalini is asking one more question. Damage to pavement layers due to utility repair cuts are so common on Indian roads. What are the desirable methods to rehabilitate with the same later without affecting the strength and integrity of the pavement layers? Fantastic question. How many times have all of you seen this, where your local city or agency, they build a brand new road, they fix a brand new road, and then the next week or the next month, either the phone company or the pipe company, whoever, they come and dig up the whole thing. And when they have dug it up, they usually just backfill it with whatever material they have, and then they wash their hands off of it to say, that's it, not my problem. Roads department is someone else. First thing, of course, to do, if you have a centralized asset management system in place, the first thing to do, of course, would be to say, the roads department would put out a notice saying, we have a road that we want to reconstruct or rebuild or repave. Is any other department planning on doing any work with it? And if yes, then we can delay our process. Or conversely, the sewer company or water company, they can say that, hey, we need to fix this water main on so-and-so road. Here's our timeline. Please make sure that you're not paving the road before. Now that they've done it, what do you do with this, with the backfill? Patching, of course, is a small-term, short-term solution. Patching does not use the same hot mix asphalt, does not use the same compaction for base. The utility companies here in the US, they are held to the same standards for reconstruction, especially if they've dug up a big channel for doing whatever work. They're held to the same standards as saying, well, if you're digging this up, we want a road back in the condition that it was. And it cannot mean that you just dump some cold patch mix on it and do some tamping and call it done. No, it has to be good material. It has to be good construction methods as well. So can that be applied right now in India? I really don't know. Everything that I've seen in my travels in India suggests otherwise, until the departments actually start collaborating and coordinating with each other. But to answer your question, it is one of my pet peeves. Is you have a nice road and then someone comes in and they just dig across, and after they're done, they just put some dirt in and say this is not our problem. No, the utility companies should be held responsible for putting the road back to the shape that it was in. I actually had a photo that I took out because I thought I had too many slides in my presentation.
Thank you, sir.
Welcome. Anyone else? Any other questions?
Any more questions? Yoshi sir?
Yeah, it is nice to listen to Salil after a long time. We had met at US last year.
Yes. Yes.
Unfortunately, I missed and I heard only for half an hour, but it was very nice and people have asked very pertinent questions. One of the major issue is the maintenance, definitely, and we do not have an asset management system practically. So it is only responsive to some damages happening to the pavement, and there is no protocol that the maintenance condition based and schedule based, it should be taken care of. But nevertheless, I think time will come that we also come up to the same, at least datum, so that we can have a very efficient system with, good impact on the safety of the road users. Thank you.
Absolutely. Absolutely. Yeah. I mean, in India, we have the technology, we have the experts, we have all the, we can send people to Mars, we can send people to the moon. We need to apply the same techniques and same level of sophistication for our infrastructure as well. It's really not that difficult. It just needs someone to say that, yeah, this is something that we are. I don't know if you saw my slides from Gujarat or not, but I told everyone that, yeah, we went on a road trip to Gujarat and we drove in rural Gujarat, and I was actually very impressed with the good quality of roads, even in rural Gujarat. So, compliments to you.
Thank you, sir. Now I request Sri Arun Chandran, Senior Scientist, to propose the vote of thanks.
Good morning, everyone. On behalf of NATPAC, I would like to extend my heartfelt gratitude to each one of you for joining us today for the 26th TransTech Talk series on the topic pavement engineering state-of-the-art practices. It has been an enlightening and interesting session, shedding light on pavement management, pavement in different countries, airfield payments, and finally the accelerated payment testing. First and foremost, I would like to express my sincere thanks to our esteemed speaker, Sri Salil Gokhale, whose expertise and knowledge have truly captivated our audience. Thank you, sir, for delivering an engaging and informative presentation. We are grateful for the knowledge and the practical insights you shared with us today. I would also like to express my gratitude to all the attendees for your presence and active involvement. Special thanks to Dr. Veeraraghavan, former Professor IIT Madras and former Research Council Chairman, KSCSTE-NATPAC. Special thanks to Sri Gaurang Joshi Sir, SBNIT Surat. The questions and discussions that follow the talk showcase your interest in the subject matter, and I appreciate your engagement. I would also like to express my gratitude to the Association of Transportation Professionals of Indian Origin, ATPIO, for their valuable collaboration in making this talk a success. As a global platform, ATPIO brings together transportation professionals of Indian origin to tackle industry challenges, share knowledge, and nurture the next generation professionals. Finally, I would like to thank our director, division heads, and the organizing team for the support that made the smooth execution of the program. Thank you, everyone.
Thank you so much.
Thank you, sir.
Yeah, thank you. Yeah.
Thank you.
She is closed.
Thank you, sir.